Hey guys, in this next video we're going to do something a little bit more advanced than beginner level. Yeah, even if you're beginner you can feel free to have a look and try to understand the key concepts. So what we're going to do here is I'm going to run the application first just to show you what it's doing. And here we go. So basically what it does is it takes a Roman numeral and it converts it to a normal number. For instance, we put in there Roman numeral V and converts to a 5. We do, for instance, IV, that is 4, as you can see. So for instance, we have here MIX, and that converts to 1009. There, as you can see. Okay, so this is basically what it does. It takes a Roman numeral and converts it into a normal number. So let's go and see how to do this. So in this case we don't have a console application, but we have a Windows Forms application. And how that works is you basically go to your Visual Studio and select New Project, and you choose your language, either Visual Basic or Visual C Sharp, Windows, and you see that at the top is Windows Forms application, and you give it a name and you will click on OK and it will open up the Windows Forms application. So this is basically what I've done here. So I'm going to take you through the code and the design on how to get this application working. So first of all, you need to create a form. You have to add a form to your project. So you will go, you right click on your project and say add new item, Windows form. There we go, there's a Windows form, and you give the form a name, whatever name you wish to choose, such as Roman converter. Click on add and we'll add the form to your project. Okay, then what we need is we need to add some GUI elements here, and on the left you will see you have a toolbox. You can also access on your view menu, and you just got to search for toolbox. There you see, and here you will have all the available controls that comes by default with Visual Studio. So let's choose a group here and say Windows Forms. So we need a button, drag it onto the form, and you go into its properties. You can basically just right click there, select properties, and add a caption to your button. For instance, convert in the text property there. Also, what we will need is a text box. Text box. There we go. Drag it onto the form like this. This is now obviously where you will type in, where the user type in the Roman numeral. Okay, and we need a label. Okay, and let's change the text property on the label. Something more meaningful, like numeral convert. Okay, right, then what else do we need? Maybe something to display the result in. Let's just use a label here as well. Do something like this. Now, in order to save time, I'm just going to go to the form I created already. Okay, as you can see here, there's a text box, there's a label, here's another, this is basically a group box, and this will be the space where you will be displaying the answer. There's your button. And now to actually get into the meat of this application, now on the button you will have a click event. So if you double click on the button, it'll take you right there. Here you can see there is a click event for the button. Now the rest of the code in this class is more or less default code, except for this line over here, and I'm going to tell you a bit more about this a little bit later. So let's look at the click event. Here we put in a try catch construct. This is to catch any errors or exceptions that might happen in order to catch the exception and have the program crash in a graceful way. So let's see here. We've got so we want to set the text property of the result label, and this is where we're going to display the answer or the converted result. Now, if you look at this line over here, it says here underscore converter dot Roman to number, and inside the brackets numeral input dot text takes the text value of the text property of the text box where the user typing is no Roman numeral, and passes it into Roman to number, which is a function in a class. So what I've done here is basically to create a class called Roman to number converter. Okay, and I've added here an enumerator which looks like this. Private enum Roman digit, you can call it whatever you want. And this is basically the structure we will store the translation. So we have the Roman numeral I, which is equal to 1, V5, X10, L50, C100, D500, M1000. And that is the extent of the numbers that we're going to work with. Right, and then the next piece of code here I'm going to explain to you is basically function that will contain the logic to convert the Roman numeral that is passed in here to a normal number, and we call it here Roman to number. Public means it's a public function, so it's accessible to classes that will inherit from this class, or from classes outside of this class in the same namespace. For instance, on the form, you can see here we say here we create an instance of that class, private Roman number to number converter equals new Roman number converter. This is the way of instantiating a new instance of that class converter. And in the button click event, basically what happens is we call the instance of this class and we call this function. Like you'll see, if you dot, it will bring up default objects or members of that class, which is built in by the system. And here you can see our Roman to number function that we created. Right. So we go back here. So this is basically our function with the logic to convert this Roman numeral. So it passes in a parameter a string parameter called Roman, and I'm going to step through this code just to explain to you how this logic actually works. So let's go ahead and put a breakpoint here. Click start, and let's try to convert a Roman numeral. For instance, we try IV, click on convert, and here the program steps into the breaking point. Now first we need an integer variable here called total. We declare it, make it equal to 1. Now this is going to contain the actual result, the end result of the calculation. Then we have int digit counter, which is going to basically be the counter that keeps count of all the digits in the string variable in the Roman. There you can see we have two digits, I and V. Okay, so this digit counter is going to keep track. Then we also declare a array list called values, and it's going to store the digits which our calculation is going to sum or total the values. Right. Then we come into a while loop. We create a while loop here. So you're going to say while digit counter is smaller than Roman.length. Now Roman.length in our case now is 2 because it contains two Roman numeral digits. So while it is smaller, while the digit counter it starts at 0, while it is smaller, it has to loop. Okay, you will see why in a short while. Next we have the base value of the digit. So we declare a variable, private variable of data type char, and we make it equal to the first character in the Roman string. We have the IV, so digit counter currently is 0, so we look at the 0 element inside the string. Okay, and that's now going to return the following. You can see here, numeral is equal to I. Okay, so if you understand this, digit counter refers, currently it's 0 as we instantiated it as 0. So it refers to the 0 element in the string Roman. Okay, and then next we want to actually translate um, the Roman numeral to a number. For instance, in our enumerator here we have here I equals 1, v5, etc., etc. So now what happens is right here we're going to say enum.parse, which is a function of the enumerator class, and we pass it in the type of Roman digit. Okay, the Roman digit is our specific enumerator, so we pass it in. You will see here the arguments that it takes. So we pass it in the numeral I, the current one, the first numeral here in the string, and it will convert it to, it will look it up as if it is in a dictionary. So it's going to say, okay, I, it's going to see what is I, what is translated to 1. So let's see here, and now digit will contain 1. Okay, so it successfully retrieved the numeric equivalent to the Roman digit. Okay, now we have another variable here, int next digit equals 0, and this is going to keep track of the next digit that it has to convert. Okay, now we say here we have an if condition. If the digit counter, which is currently 0, is smaller than the length of the string, of the Roman string, with the Roman numerals, minus 1. Remember, you have to say minus 1 because it's 0 based. So there's currently the length is 2, so there's 2 elements. Okay, but it's 0 base, so it starts counting at 0 and not at 1. So if you say minus 1 here, so it's equal to the length 2 minus 1, so it's going to say Roman element 0 and element 1. Okay, so if it's smaller than this, then the length of the Roman string, it has to step in here into this section, and then it's going to say, okay, right, so next numeral, what is the next numeral that we have to translate? So it goes into the Roman string, and it receives here the, um, you pass it in the index. Now it needs to check digit count is 0 currently, plus 1, so it's gonna pick up the next numeral, which is V. I and V. I is the first one, V is the second one, so this is the next one. Now it's got to calculate. Right, so now once again it has to retrieve the Roman numeral. It's got to translate it into its number equivalent, and then we see it's 5. So V is obviously equal to 5, and you can see V equals 5. Now we've got to check. So if next digit, which is 5, is greater than digit 1. If it is, then obviously now it has to subtract. It has to subtract digit from next digit, because now we have I and V, and how the calculation works is you have to say V minus I. Okay, so going here, so only if next digit is greater than the current digit, then we will perform the subtraction. Okay, so we say here it's equal to 4, because 5 minus 1, 4. Sorry, next digit 5 is minus 4 equals 4 right there. Okay. Okay, and here we store the result, which is 4. We store it into the values array list. We increase the digit counter, and now you say, while digit counter is smaller than Roman.length, okay, now it is not smaller anymore because it's already 2. Okay, so it has no more calculations to do. Now we want to sum total all the values, and there's only 1, so it's only going to go in there to iterate only once, and here we return a total which is 4, and the result is 4. Okay, so let's try another one. Say what can we use? Let's say something like okay, let's use something that doesn't have to do a subtraction. So for instance, xv. Okay, once again we step into the code and we go into the while loop. Okay, the first one is x, the first numeral there. Our string that we passed in is xv, so the first one is x. Okay, it looks up what x is in the numerator, and it's equal to 10. You can see here it's equals to 10. Right, now it's going to check if the digit counter, the current counter, is smaller than the length of the string. Yes, it is still smaller, so it's valid. It has to go in here. Here it looks up the next one, which is v, next digit, and now it does translation, and it checks to see what it translates to as 5. Once again, we have to do a check to see if next digit is greater than digit, and it is not. 5 is not greater than 10, so it doesn't have to perform a subtraction, so we're simply going to add it into our values and our array list. Alright, and once again step into the while loop because digit counter is now 1. It's still smaller than the length of our string, which is 2. So it has another character to translate here. And you can see now it didn't go into the if statement here because digit counter is now is not smaller than the length of our string. So it simply adds the next digit into our values array list, which currently has two values, 10 and 5. Okay, and do the sum. We step into a for each loop, and for each digit in our values array list, it's just going to say plus equals. Just going to total it up. Then, okay, once again, currently it's got 10 plus equals 5 equals 15, and there it returns our result. And there you go. 15xp comes down to the result of 50. And that is basically the gist of it here, how to convert Roman numerals into a normal number that we can understand. And there we go.